Hi, welcome to Adding and Subtracting Rational Functions. So the essential understanding for this video is we're going to be able to use knowledge of working with fractions to add and subtract rational expressions. So the example that we have to start off with is 1/2 plus 1/3. And we know that we can't do this because the denominators aren't the same. So first we have to find the LCM of denominators, the least common multiple, and then we have to multiply and finally simplify. So we have the original problem down here, 1/2 plus 1/3, and we multiply the 1/2 by 3/3 so that the denominator is 6, and we multiply it by the equivalent fraction of 3/3, and then we multiply 1/3 by 2/2 so that this denominator also equals 6. This comes to 3/6 plus 2/6, which we know equals 5/6, and that is how that works.
Helpful hint: to find the least common multiple, make sure you multiply the denominators.
Okay, so the first thing we have to go over is what is the LCM. To find the LCM of 12x squared y times x squared plus 2x plus 1 and 18x squared y squared times x squared plus 5x plus 4, we have to first find the prime factors of both of these expressions. So for the first one, the prime factors are 2 squared times 3x squared y times x plus 1 raised to the power of 2. And then for the second expression, the prime factorization is 3 squared times 2xy squared times x plus 1 times x plus 4. The next step to finding the LCM is writing the product of the prime factors, so multiplying these two together without repeating a factor. So this is the answer, and you see we get the 2 squared from here, and then there's a 3 squared. And so there's a 3 squared here and a 3 here. And we don't want to repeat the 3 because, as it says, we don't repeat. So we take the power, the highest power, and keep it with the 3. And we only write the 3 once. That's the same thing for the x squared and the y squared. You can see there's an x squared here and an x here. So we bring down the x squared. And there's a y here and a y squared here, and we take down the y squared. Same thing with x plus 1 squared and x plus 1. We just take down the x plus 1 and add a square to it because that's the highest power that it's raised to in these two expressions, and then we just take down the x plus 4. That's not repeated, it stays the same. When simplified, this goes to 36x squared y times x to the third plus 6x squared plus 9x plus 4, and that is the LCM.
Helpful hint: when there are identical terms, make sure that you carry only the greatest power to the least common multiple.
Okay, so now we're going to go over adding rational equations, which is one of the main things that we're going to do today. To do that, we first find the LCM, which we discussed in the last slide. We then multiply by equivalent fractions to make the denominator equal to the LCM. We will add the numerators once the denominators are equal, and finally simplify. Okay, so this is an example of addition. The problem here is x over x minus 1 plus 2x minus 1 over x squared minus 3x plus 2. We just rewrote it over here, and then we factored out this expression because we have to find the prime factor first to find the LCM. So we factor it out. We get x minus 1 times x minus 2. And x minus 1 can't be factored. That's the prime factor of x minus 1, so we leave it the same. When finding the LCM, we know we multiply these together, but we don't repeat a factor. So x minus 1 isn't repeated, it's only written once, and since it's only raised to the first power, the LCM is x minus 1 times x minus 2. The next step to addition is getting both denominators equal to the LCM. So this second fraction, the denominator is already equal to the LCM. So we just have to work with the first fraction. The first fraction already has a term of the LCM in it, which is x minus 1. So all we have to do is multiply it by x minus 2. Now, one of the helpful hints that Michael gave was that when we multiply this fraction, we have to make sure that the fraction we're multiplying it by is equal to 1. They have to be the same expressions on both sides of the fraction line. So we multiply both sides by x minus 2. When we do that, we get this up here, which is x squared minus 2x over x minus 1 times x minus 2, which is the LCM, and then plus 2x minus 1 over x minus 1 times x plus 2, x minus 2. So now we've achieved we have both denominators equal to the LCM and equal to each other. So then we simplify. We add the numerators together. The negative 2x and the positive 2x cancel out, so we're left with x squared minus 1 over the LCM of x minus 1 times x minus 2. This is the difference of two squares pattern, so it factors out to x plus 1 times x minus 1. And then we see this equation, and we see there's an x minus 1 on both sides, so those can be canceled out, so we can cancel both of those out. And then we get, in our final answer, x plus 1 over x minus 2, and that's your answer. But you have to make sure you acknowledge the domain restrictions, which is x, it can't equal 1 or 2, which we know because in the LCM as well as the denominator here and here, x minus 1, if we put a 1 in here, the denominator would equal 0, and if we put a 2 in here, the denominator would equal 0, which we know we can't do. So these are our domain restrictions, and as you see here, this is point, what's the word where you like, where you like these removable discontinuity because it's removed here, but this is non-removable because it remains and it can't be removed.
That's fine.
Okay, so subtracting rational expressions is very similar to adding rational expressions. Like adding, we find the LCM, we multiply the two fractions by equivalent fractions to get the denominators equal to the LCM, and then we subtract the numerators instead of adding, and finally we simplify.
Helpful hint, when subtracting, make sure you distribute the negative.
Okay, so this is our example of subtraction, which you can see is actually the same as our one for addition, except it's now being subtracted. So we have x over x minus 1 minus 2x minus 1 over x squared minus 3x plus 2. And we factor this out because we have to find the prime factorization of these two, just like we did with addition. It factors out to x minus 1 times x minus 2. And we see that that is our LCM because, like I said before, you don't repeat, and x minus 1 is just raised to the first power. So this isn't repeated, and the LCM is x minus 1 times x minus 2. So to get x over x minus 1, to get the denominator equal to x minus 1 times x minus 2, we multiply it by x minus 2 over x minus 2. When we do that, we get x squared minus 2x over x minus 1 times x minus 2 minus 2x minus 1 over x minus 1 times x minus 2. When we simplify that, we get x squared minus 4x plus 1 over the common denominator of x minus 1 times x minus 2. Again, we have to note our domain restrictions. X can't equal 1 or 2 because I said before, if it did, the denominator would equal 0. Thanks for watching.